Okay, so today we're going to talk about Newton's first law of motion. And one of the things I want you to know about Sir Isaac Newton was that he was born the same year that Galileo died. So they were never alive at the same time, but yet Galileo had a profound effect on Sir Isaac Newton. So Newton's first law of motion is called the law of inertia. And we just studied the law of inertia, what inertia was, when we studied Galileo. But what Newton said, what his first law of motion says is basically that you don't need a force to keep something in motion. You need a force to start something in motion, but you don't need a force to keep something in motion. And that was totally different than anything anybody had thought of before other than Galileo. So Newton's first law of motion literally says a body at rest tends to stay at rest. A body in motion tends to stay in motion at a constant speed and in a straight line, unless it's acted on by an outside force or an unbalanced force. Now, we've been studying forces a lot, and we know that when something is at rest and all of the forces are balanced, that's called static equilibrium. We know when something is in motion in a straight line at a constant speed, that's called dynamic equilibrium. And how you can get disequilibrium, or how you can get things moving or changing, is to provide an unbalanced force. So the equilibrium rule says the sum of all forces equals 0. That's when something's in equilibrium. And this says the sum of the forces are no longer going to be 0. There's going to be a change. If there's an unbalanced force, then this no longer holds true. So let's talk about some examples. Objects at rest. Things tend to do what they're already doing, and in this case, if they're at rest, they're going to stay at rest. Only a force causes things to move. Now I want you to think about you're sitting in a car. You're waiting for your brother or your sister or whoever to get into the car, into the driver's seat. And they drive like a maniac. They start the car, they slam on the accelerator. What happens to your body? When you move forward quickly, your body does this, doesn't it? Your body goes back. If you think about it, it makes sense when I say a body at rest tends to stay at rest. Your body was at rest. It wanted to stay at rest. It didn't want to move. It wanted to stay where it was. So when that unbalanced force, that gas being stepped on for the car, occurs, your body goes, wait a minute. It does eventually move, but you can all feel it in your body when your body is at rest and it wants to stay at rest. That's true whether you're at a red light and you start to go, or whether you're in your driveway. Both exactly the same. If I had a baseball in my hand right now, and I didn't provide it with any outside forces, that ball wouldn't suddenly start floating or falling or rolling to the left or the right. It would just sit in my hand because it was in equilibrium and there were no unbalanced forces. So what about objects in motion? Objects in motion, and we're going to say without friction, because we're going to talk about friction. We talked about it a little bit with Galileo already. So we're going to say without friction, once things begin to move due to a force, they will continue to move in a straight line at a constant speed unless they're acted on by an outside force. So again, let's picture yourself in the car. You're driving down the road at 35 miles an hour, 45 miles an hour. The light ahead of you turns red. Your brother steps on the brakes, and what happens to your body? You do this. Normally you're having your seatbelt on, which is going to help provide that force and give you a little bit extra time. We're going to talk about how important time is later on, but give you a little bit extra time for you to slow down. But what literally happens is your body's in motion and it wants to keep being in motion. It's not allowed to keep being in motion. There's something that stops it. It's the outside force. The car stopping, the seatbelt stopping you. That's your outside force. Likewise, when you turn, if you're in your car and your brother or sister makes a left-hand turn, your body leans to the right. And that's because your body wanted to continue going in that straight line, but the force makes it go to the left. So it makes sense that you're going to go to the right when you make a left-hand turn. Next time you're in the car, pay really close attention to how your body reacts to outside forces, speeding up, slowing down, changing directions. You'll see that Newton's first law of motion is absolutely correct. A body at rest tends to stay at rest. A body in motion tends to stay in motion at a constant speed and in a straight line, unless acted on by an outside force. That's also known as the law of inertia.